Hey guys, my name is Rachel Higgins and I'm going to be talking the chemistry of tattoo ink. First of all, I want to apologize because I cannot get my PowerPoint to record my presentation at all. So I am recording on my phone because I want to turn this in, but I emailed the professor and hopefully she gets my email, and so yeah, we're gonna go. So basically, I'm just going to talk a little about what are tattoos. Tattoos are when you get needles injected to your skin and it shoots permanent ink into your flesh. It goes straight into the second layer, which is referred to your dermis. Also, fun fact, I don't know, it kind of hurts, but it's not like fun. But your skin is pierced 50 to 3,000 times per minute by a tattoo machine. Like, when I actually read that, I was just like, whoa, what the heck? That is, I never really expected that many times, but yeah, it's crazy. So, this presentation, I'm more on history and talking about the chemistry of the ink, but I'm also talking about what it does to like our skin and stuff. So when the tattoo needle punctures your skin, obviously it causes a puncture. It causes a tiny wound because it's needles going into your skin 50 to 3,000 times a minute. So basically, when you get an open wound, cut, or anything, a macrophage, it sends to macrophages to close the wound. But macrophages are a large white blood cell that is an important part of our immune system. It has the ability to locate and eat or destroy. I like to use the word eat for some reason because it's like basically, it's eating all the bad stuff out of your skin. But it takes all the bacteria, viruses, fungi, and parasites out of the open wounds so you don't get sick or it doesn't get into your bloodstream, so forth, so forth. But in the case of a tattoo, the pigment particles are too big for the macrophages to actually destroy it. And it's basically stuck in your skin. That's why it's called permanent ink. So, yeah. But the cool thing is when you can obviously get tattoos removed by laser treatment. And basically what that does, it breaks the pigment particles into something smaller enough for the macrophages for them to destroy. So I thought that was pretty cool because it can just heal your skin back. Okay, so this is kind of not in my topic, but I just, for some reason, when I learn chemistry, I just love learning. I like talking about physical and chemical changes for some reason. It's like the easiest thing that you can learn, but it's honestly, when I seen this, I was like, yeah, okay. So, is a tattoo a physical or chemical change? Obviously, it's a physical change. Does it do anything chemically to your body? But it physically changes it. Your skin is the same as it was before you were tattooed, but now it's ink shot into your skin and you're bleeding, but nothing chemically changed to your body, so it's a physical change. Okay, so now let's get into the chemistry of ink. So here's a little history background. Not really much of anything, but the oldest pigments used in tattoos came from using ground up minerals and carbon black. Pretty much back in the days, anything they could find in the environment and that they could grind it up or anything to make it look like a color, they could have mixed it into a carrier and made it into ink. So easy. Honestly, it's the best way to make an ink and the safest way, but they've literally there's so many different, I read over 200 pigments. That's not the best thing for you, but it's also FDA approved, so I don't even know. But basically, an example of that, so what people would do is they would burn their wood to ash, and then they'd use the ash for black pigments. That's literally what they did for a tattoo. So, tattoo inks are made by a carrier and pigments, or the other word, I can't remember. It's in the other side, but I'll let you know. But tattoo inks are made by a carrier and pigments. A carrier is a single substance or a mixture, basically liquid, like sterilized liquids, and you literally mix it with a pigment. That's a carrier. But the purpose of the carrier is to keep the pigment evenly distributed in a fluid matrix to prevent clumping of pigments and to help the application to the skin. But there's some of the things that are found in a carrier: alcohol, purified water, witch hazel, basically any sterilized liquids that you can use. There was like a huge list, and I just put those three because we know that most of them, literally everything, sterilized liquid. Colorants, that's the word. I'm sorry, I literally went over this like 5 times. Tattoo colorants are pigments. Yeah, but it's obviously easier to remember pigments and to say pigments. But these are colored compounds that can reflect light in the visible region of the light spectrum. I basically thought this was cool because it was with my topic, and we literally had this in our last lesson, so I was like, obviously I have to do this. So here are some of the tattoo ink pigments that they use today. These are the same compounds and elements that they mix to make colors. Yeah, those. Tattoo pigments, moderate day pigments, are either made up of organic, industrial minerals, mineral pigments, vegetable-based pigments, or plastic-based pigments. These are, like I said, these are the moderate ones that we use today. They still, they don't use, what they used to. But it's honestly, I just kept reading and these are FDA approved, but they're not the best solution. And it said something about tattoo parlors and tattooers do make their own pigments and stuff, and they have to go through the FDA approval and stuff like that, so they can actually have their own tattooing and stuff. It's just, yeah. So here's some of the organic pigments, because I also read this thing on this article where it talked about they were starting to use more organic pigments and stuff. Ozone pigment is an organic pigment, but yeah. But it's basically the largest chemical class of compounds from which pigments are made. It makes up red, yellow, blue, and orange. And then the organic pigments are based on carbon chains, carbon rings. They can also contain metallic elements that help stabilize the properties of organic components. And then there's some examples of organic pigments. These are commonly used. So safe alternative pigments. The safer pigments, like I was talking about earlier, safer pigments for tattoo use are usually naturally from the environment. Like I said before, I honestly wish we could still use the safer pigments, but it's just easier for people to get all the easy stuff. But I know that India still uses the natural from the environment pigments. I read about how they have a bunch of colored red tattoos and stuff. But I just they're just so much better. But that is it for you guys. Also, sorry for the horrible quality. Also, these are my tattoos because I just love tattoos, and I was like, hey, I want to put my tattoos on here. But yeah, sorry for the horrible situation. But at least I did it, so. But thank you guys.